Hello guys, so today we are going to do a re-entry into the atmosphere from International Space Station. So this is going to be a fairly simple tutorial. I really hope I will survive and we will not burn in the atmosphere or crash our aircraft because I'm doing this live. So without further ado, let's begin. So um, First of all, let's check out. Inner door is closed, outer door is closed, and we have chamber pressure. There's air, so we can click Ctrl D and detach from International Space Station.
Undocking confirmed.
At this point, let's go to the glass cockpit and go to the orbit. Click PRJ to see the orbit and click distance in order to get our altitude from the surface of the Earth. We can use our retro doors to
APU offline.
Okay, first of all, let's open the auxiliary power unit, then open the retro doors and just use the retro thrusters to drift away from the station. Now we can close it down. So let's see, our target is Cape Canaveral. This is where we're going to land. Cape Canaveral. And let's zoom in. And now we just have to make sure that we will be above the Cape Canaveral. So you see this circle? This is the target. And right now our swipe around Earth is not aligned with it. So what you have to do is you have to accelerate the simulation in order to get to the point where the our trajectory is going to be above this target. So it doesn't have to be like exactly above, because we can do some corrections to the left or to the right during the re-entry, but it's better to be pretty close. So at this point, let's just
Information. APU running.
let's close the APU, let's shut off the APU so we won't use too much fuel, and accelerate the simulation. And basically we have to wait that the swipe is going to be above the Cape Canaveral. So, okay, we arrived on the last sweep before we hit the atmosphere, and this sweep is going to take us, if you can see on the left MFD on the map, straight above the Cape Canaveral. So this is a good trajectory here. And at this point, what we need to do is we need to start preparing for retrograde burn. Now, as a rule of thumb, what I'm doing, at least when I'm returning from the ISS, which is International Space Station, the rule of thumb is to start retrograde burn around 17 to 18,000 kilometers away from your target base. So right now we actually increasing the distance here because we didn't went halfway through the globe. But soon it will happen. It will start to decrease. It will start to decrease the distance between us. And at around 17,000, we will do the retrograde burn, or you can do the prograde, but use the retro thruster. So I think this is what I'm going to do. We'll put this on prograde mode. Let me just put the HUD display on orbit. And at this point I also open the aerobrake MFD and put the target as Cape Canaveral. And let me just get rid out of this information. So this is the window that we want to look on. So this window actually tells us the point of impact. So the green line is our location, this is our trajectory, the yellow line is the target, which is Cape Canaveral, and the white line is the point of impact. So we want to make sure that this line is going to be on top of the target. But at this time, let's wait for the distance. And at around this time, we can engage the retro thrusters. Let's just take the
APU offline.
Okay, let's Let's power up auxiliary power unit and open the retro doors and use the retro thrusters. Now you need to be delicate with this thing because when we're looking for the right screen, we see our orbit diminishes, and at the end we need to make just a slight input of thrust. Okay. Now just bit by bit we'll put the white line on top of the yellow line, like that. And we finished the retro burn. Now at this point we can close the APU for a while, and what we have to do now is we need to put ourselves in the correct orientation for the reentry. So the reentry angle should be at around, the angle of attack during the reentry should be around 40 degrees. This is like the optimal angle. And for this we're going to use the autopilot. We're going to do the automatic reentry. So let's put the pitch at around 40 degrees. Before you engage the autopilot, make sure that you are pointing your nose into the direction of your flight, which is the prograde, the velocity vector, okay? And because sometimes you can drift to the left or to the right of your flight vector, and it will make the prediction wrong. So now we can engage the attitude at 40 degrees, and we will see how our prediction works. So you need to understand that this prediction is going to be changed constantly based on your attitude and based on other stuff. For example, with time you will see that the prediction is the offset is getting bigger because there is like a slight there is some errors in prediction, so we need actually to correct it every time because the error develops over time. So let's put our HUD's display on surface so we can see the altitude. And right now we see that the prediction is actually wrong, so we can... Right now we're actually going to overshoot the target, so we can use the retro thrusters again to correct this. So at this point, just make sure that every now and then you actually make a correction, but be aware that when you reaching, the more time passes until you reach the reentry interface, the harder it is to make a correction. And at some point, even if you make a correction, the angle is going to be still pretty steep, for example, or shallow. So you need to kind of space your corrections in time since the beginning of the burn of the reentry of the retrograde burn and until the reentry interface. So right now we are okay. Okay, so at this point we are 140 kilometers above the ground, so we need to make our final preparation for re-entry. So we're going to close the retro doors and we're going to stow our radiator, and I think we will going to make sure that our APU is working. Test the lights. And we will make a re-entry checklist. Page number 9.
Entry check. All systems green.
Everything is on green, so it's okay. So we have our HUDs on surface mode, we have our RCS mode on rotation right now. And at this point I think I'm going to use the angle in order to fix our trajectory. So we are around 4,400 kilometers away, which is a good re-entry place above Canada, just crossing the Canadian West shoreline. And it's already morning. So now what is left is to observe. Now, just something to look at. There is a re-entry profile prediction, which gives us important information that we are going to use during the re-entry. So this graph shows us the graph of the heating, deceleration, and our altitude. So what is important mostly for me is it's the heat. It will show you when you will reach the peak of your heat temperature, the highest temperature during the re-entry on your airframe, and I will going to use it combined with the page number 3, which shows us the temperature of the airframe of our aircraft beneath and our heat shield. So right now the temperature is decreasing, and this is the external temperature. And we want to make sure that we are in green and yellow. If we're going to red, it's already dangerous. So if I will see that I'm going to hit red and we still didn't hit the peak of our heating, then I will have to decrease the angle to try to save the aircraft. Bear in mind that sometimes even this is not enough if you on a really steep angle. So there's also deceleration, which is not that dangerous, or you are plunging towards the earth, but you're probably going to burn out before that, before you will overstress your airframe. And there's this is the altitude, so we're going to descend around 50 kilometers and stay at this altitude, and then we're going to plunge down to earth. Let me just and if you want to see deceleration, so z-axis is actually our deceleration. So z-axis acceleration shows us the backwards and forwards acceleration in meters per second.
60%.
So 10 meters per second is around 1 g. You can know how fast we decelerate, and that's it. So now we hit the re-entry interface. We already hit the atmosphere on 94 kilometers, and the static pressure is already starting to rise. So let's check where we are going to land now. Right now we're on overshoot, so let's increase the let's do this slightly more.
Okay, Jeff, we
fine.
What you have?